Well, hello everyone and welcome back to Adrian's Digital Basement 2. Today we have a chill video where I'm gonna work on some old MFM hard drives. So this right here is a Seagate ST225. It's a 20 megabyte Type 2 drive, of course MFM. I recently made a video where I tested a bunch of, I talked about a bunch of MFM drives, how you get them working, and then in the second video I tested out the drives to see if any worked, and actually, none of them worked. If I recall, that was the outcome of that video. I will link in the description below, of course, to those videos, so check those out if you haven't seen those already. Those were on the main channel. This drive right here was one of the drives that I tested, so another ST225. I wrote spins, but not working. So this spins up and it makes some kind of noises like the head is seeking, but it doesn't seem to do anything else besides that. The computer reports an error. Now I have a working drive here, this one right there, because I have decided that I'm going to swap the controllers between these two drives, and we're going to find out if it's the controller on this bad drive that keeps it from working or something inside the drive itself. And if that's the case, well, maybe I'll do what I did on the main channel video. We'll open this up and take a look inside, see it working and stuff like that. I have a couple other hard drives here. This is, well, let's take a look at what this is. It's a Miniscribe, obviously. I'm struggling to read the model number there, but I wrote no spin on there. The date, 18th of June, 1987. And yes, this is not a brick, it's an actual hard drive. And yeah, Miniscribe made both 3.5 inch and 5.25 inch MFM drives. And this is one of the 5.25 inch variety. It still has the stepper motor in there, or it's like a regular stepper motor that controls the head assembly. So it's not a voice coil. The Seagates, on the other hand, the stepper motor is right here, but it is turned, well, what, like 90 degrees versus the one on this. Sort of operates with a little rack and pinion system inside, I think. I think that's what's going on. We have another drive here. This one spins up, but it says drive error. The drive is an NEC and is model number D5126. It's also got a stepper motor here and a warning sticker that says, warning, do not, under any circumstances, I'm adding that part, rotate the stepper header or disk damage may occur. Uh-oh. Underneath the sticker here, looks like we just have that, which is, I don't know, to avoid damage to the drive, keep dry. So it's like some air vents. Anyhow, yep, MFM hard drive as well, stepper motor as well, pretty run-of-the-mill stuff. As I said, this thing spins, but it just says drive error. So that means that it's never asserting the drive ready signal back to the controller, which I think that's the same problem that this Seagate has as well, this one right here. I also have this hard drive here, which is a Control Data Corporation drive from 1988. Now this is a 43 megabyte drive, and this thing actually works fine. I was just testing my bench setup here just to make sure that the controller and the cabling and everything is good. And yeah, this drive is working properly. It's got a plastic cover on the bottom here, the regular connections there, and let me unplug the power cable here so I can show the back. There's also a PCB on the back of the drive there, and a metal chassis, and obviously being from 1988, that's kind of late in the game for these types of hard drives. I mean, I don't remember when the first IDE drives came out, but I gotta think it was around this time, although maybe not. Let me plug this back in and we'll just show that this thing is working. What's cool about this drive, this control data drive, which, let me see if I can figure out the model number on this thing. Model number 94205-51. Lots of numbers there. It's a Class A peripheral computing device. FCC rules, warranty void, if removed. And while I have my goggles on, let's take a look at this Miniscribe drive again. So Miniscribe, I don't know, HDA 52996. Could that be right? July 18th, 1987. So a little bit later than the sticker here. I guess that's when it was certified. There's a serial number. Oh, here we go. Miniscribe, model number 3438. That's gonna be hard to read because that's a stupid silver label. There's a serial number. And yeah, that's it. That's not much else to report. Now the fact this doesn't spin means we might have to open this thing up and give it a little help spinning. And now I haven't done any troubleshooting on these drives. Oops, sorry about that. Haven't done any troubleshooting on either of these drives really. And the only one I've done any testing on is that Seagate under there. That was in the previous video. These two have never been seen up until this point on the channel. Alrighty, so the Control Data Corporation drive is connected to the 486 lab PC there. Let's turn this on. I have the computer sitting over here, so that way the monitor should be in focus, because lately I've been doing, well, I've had a few videos where the computer, like the motherboard and cards, were in view of the camera and it focused on those instead of the monitor. So this should boot up. Whoops, okay, sorry, it's booting up off this disk. Let's take the disk out of the drive. So there we go, we don't need that. And this is a pretty quick drive. There it is, it booted right up. In fact, I'm gonna put check it in here because we're gonna look at how fast this drive actually runs, because it seems to be pretty speedy. And obviously this is using a voice coil inside this drive here because it's very quiet, the operation. I mean, it's making a noise because the drive is spinning, and that's typical for these older drives. But when you're doing random seeks and stuff, it sounds very quick and fast and yeah, nice basically. I am hoping that this text is going to be somewhat readable. I will be zooming up closer on the screen when we have more relevant stuff to look at. And I bust out this larger LCD than the normal little NEC that I use. All right, we're going to do the old hard drive benchmark here in Check It. Let's zoom in a little bit. 289K per second. And keep in mind, I have not done any kind of, well, oh, by the way, yeah, look at that seek time. 26.3 millisecond, and track to track is 3.9. Anyhow, as I was saying, 289K per second. I haven't done any tweaking or testing of the interleave. In fact, let's just run SpinRite 2 quickly and let's see what the optimum interleave is on this particular computer, because this is a very fast computer compared to an original XT. So this is SpinRite 2 by Gibson Research, and this is pretty much one of the best utilities there are for figuring out like the best interleave for your drive. You can adjust the interleave by re-leveling the whole hard drive, but this program lets you change the actual interleave without erasing the hard drive. So you go to Begin SpinRite Analysis, and unfortunately it's a little bit of a slow process to get to the screen we're looking for, which is the interleave screen, but I'll just cut that part out of the video. While this test runs, I wanted to point out that I'm using the good old Western Digital controller that I showed on those main channel videos, the really nice gold board here. And the funny thing is, I grabbed another MFM controller, this one right here, which is an NDC 5525, and it's a 16-bit controller. It should be similarly performant as the Western Digital controller there, but this controller sucks. It works, but its read speeds, at least with this control data drive that I have hooked up now, is incredibly slow. Like, we're talking, it reads at like 10K per second, something absolutely abysmal. And at first I thought there was something wrong with this hard drive, and then I hooked up this controller card and everything was fast and was working properly. So this card is just not working correctly. And I've already double checked all the jumpers are correct, and they are. There aren't really any jumpers for performance stuff. It's more just for like the base IO and stuff like that. Everything is fine, and I don't see any damage on this card. There's nothing wrong with it, but it just sucks. So I'm not gonna be using that card anymore. All right, so this is a system parameter screen. So maximum data rate, 522K per second. And we saw on Check It, we were only getting like 200 something K. So the interleave setting is wrong. I think it's just set for 1-to-1. It should be faster. So we'll be able to determine that in a second. But you can see the RPM of the drive. It's just off ever so slightly from the normal 3600 RPM, but that's not really a problem. All right, here it is. It's checking for the interleave settings. Okay, okay, I guess I am at the optimum interleave. You can see here that 1-to-1, which is what it currently is set to, there's current, is 522,000, and it kind of goes down from there. If the machine were slower, the interleave, the optimum interleave would be one of these other ones, and what you would see is it would kind of slow down as you get worse and worse. But say 2-to-1 was the optimum interleave for this machine, if you were on 1-to-1, the performance would be like 1/10 the speed. It would be incredibly slow. So you really want to make sure you have the optimum interleave, but I guess when you're talking about a pretty fast 46 DX266, which this machine is, then the optimum interleave is 1-to-1, so we're already at it. Okay, enough of this control data drive. Let's park the heads. Let's exit out of here. Remember to park your heads, okay? Park. And then we are going to turn this off. Now this drive, incidentally, it does have auto parking, but when you can hear, well, when you turn the power off, if you haven't parked the heads, you can hear it parking, and the head kind of goes like bump, 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 like bumps into the bump stop. But since it's parked now, that doesn't happen. It doesn't really do anything when you turn it off. It's just nice and silent. All right, let's start with this NEC drive. I took this out of an XT computer, which had like a dedicated controller. So to be honest, there may not be anything wrong with this drive, and it might be a problem with the controller that was in there. And you know, I didn't really do any exhaustive testing. I just booted the computer up and saw that it didn't really do anything. It just reported a drive error and just sort of moved on from there. So I'm gonna hook this up to my known good setup here, and then we'll give this thing a test. I will need to look up the drive type though, because I have no idea what the drive type is for this. But if you're ever in doubt, just set it for type 2 and you will at least get 20 megabytes. I don't think any of these drives, any of these like half-height drives, are gonna be any smaller capacity than the ST225. So usually type 2 is like a safe bet for it actually working, at least at a rudimentary level. Googling for the part number though, this is a D5126. It seems like it's got the exact same heads and cylinders as the 225. It's got 615 cylinders, 4 heads, 17 tracks per sector. So that certainly sounds like a type 2 drive to me, which I think was pretty common. Lots of people were copying what Seagate was doing with the ST225. And the thing is, remember I talked about in the last video, the 8-bit controllers have their own BIOS on them, and they often have fixed hard drive types that are specifically, you know, for a type 2 drive, for instance. So if you have one of those and you plug in this NEC drive, it should just work. Anyhow, let's turn this on. Okay, I think there might be a head crash on this because as it started to spin, there was a little bit of like a tick, 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 tick sound as it was spinning up, which kind of gives me the idea that this thing has like a spot on the disk that is bad, and as the disk spins up, the heads pass over and, you know, a problem occurs. So let's see here, how do I switch this to type 2? There it is, type 2, yes. 615, 4 heads, 17 sectors. Pre-compensation is on, at least with type 2. Let's see if this thing even needs pre-compensation. Whoops. Yeah, pre-compensation on here, it says 128, I think. It's really hard to tell with this text. It's not really formatted properly. Yeah, 128. So I guess I should do a custom type and change that from 300 to 128. Okay, so these are the settings that were on that web page. So we'll just save out of here. Now I've booted off the floppy disk here, so we're gonna run Superstore. Actually, let's just see if there's anything. Okay, so invalid drive specification. So we're gonna run Superstore, or is it Speedstore? You know, I got that wrong last time. I should probably just write out, this is a little auto exec bat that I'd written. I should probably just spell out what that is, just to reinforce in my memory that it's Speedstore. Yeah, Speedstore, here we go. All right, so first thing we're gonna do is diagnostics, and obviously the controller test is just gonna pass. That just tests that your disk controller in the computer is working. Seek test. All right, well, it is seeking. There's a red light on there. Let's move that out of the way so you can see that. Red light's on, and it is seeking. The little stepper motor is doing its thing. So that's a good sign. That drive is responding to commands, at least. It was telling me that the drive just wasn't ready with the original XT controller, and this is actually working. So there's a good chance this drive actually just works. So I'll show you the steps I use to low level a drive like this. All right, well, this is an extreme test here, so we're not gonna bother, so we'll just abort out of this. You can do read test, write test, media analysis, stuff like that. But what we're gonna do is manual setup, and we are going to initialize the drive. We're just gonna do a standard init. It's gonna say it's gonna erase everything on there. That's fine, because we didn't seem to be able to read it anyways. I'm not gonna enter any locations. In fact, this drive didn't have anything written on the top. There was no bad locations because, I don't know, it doesn't matter anyways, because you could just skip this and it can scan and figure out which sectors are bad while it's doing a media scan anyways. Here's the interleave. We know 1:1 is the correct setting for this particular computer because it's fast. Your mileage may vary, as I just talked about using SpinRite. So 1, here we go. Hey, it's initializing. This means it's working. If the drive were not responding commands properly, it would just get stuck and that would not actually move. So that is actually going. That's cool. I think this drive is gonna work great. Now the low-level format is proceeding seemingly normally. It hasn't even got to the scanning. Well, first it does a format, then it scans. So there still could be a problem with this drive. Like it might not read properly, and we'll figure that out pretty soon. The thing is, what I have found is that some old hard drives basically can appear not to work at all, but then once you give it a fresh low-level format, it seems to work again. And I think what might be happening, and I mean, people who know more about this can definitely chime in down in the comment section. But we have to remember this is like spinning magnetic oxide, iron oxide on metal discs, right? So it's actually writing the data into that magnetic oxide. It's just like on a cassette tape or a videotape. And I think what might happen over time, I mean, this drive may not have been used for a very long time. Maybe the information or like the magnetic signal that's actually in that iron oxide fades over time. Like it loses its ability to be read out properly. And when you do a low-level format, because of course, you know, these cables are hooked up directly from the disk controller here to the drive electronics. There's not a whole lot going on here. There's just write and read amplifiers and stuff to control the stepper motors and the speed of the disk and stuff like that. But really, this cable here, this smaller cable, is carrying all the read-write data and is going directly to the read-write amps, you know, to the heads. So low-leveling the drive is something you can't really do on IDE drives because it's literally relaying down a fresh set of blank data onto the disk. It's like it's doing the lowest level format. And that's just something that isn't possible on SCSI and IDE drives because all of the drive electronics with the controller is all sort of hidden away from you. And by the way, it's actually doing the media scan right now. It's scanning the drive for defects and it's going quickly and it's working. So I think this drive's gonna work great. So anyways, a low-level format, from my understanding on a drive like this, is laying down a fresh coding, a fresh signal basically of all the sector layout and stuff like that onto the disk. So then later you can go and do fdisk and add a partition and then do a regular DOS format on it. And you need that underlying structure for the drive to be able to like read where the sectors are and stuff like that. Now this is to the best of my understanding. I don't fully understand how it works, but I do know that you do have to do a low-level format on these drives before you can use them. And this drive, whatever was on here, or whatever information was on there, if I tried to read the disk, like do a read test, it would have just failed. If I tried to format or partition the disk with DOS, it would have failed. You gotta do this low level first. That just sort of puts down that base information before it'll work. And look, initialization is complete. That freaking worked. This drive is working. So I'm gonna exit out of the initialization menu and you can actually partition the disk right in this program. So it's like, it just does an fdisk basically. So we'll just create a DOS partition. We're gonna say the largest. So it made you know, DOS 3 or later, 21 meg or 20 megs or so before. And you can actually format the disk. I won't do that. I will just exit out of here. Exit yes. You do have to reboot if you have created a partition table. And that's because DOS reads the partition table as it boots even off the floppy disk, and it needs that for fdisk to work properly. So anytime you do a new partition, you just gotta do a quick reset or reboot of the computer. What was I saying? First of all, let's format this. Format C/S. This is DOS 622. Oh yeah, I know what I was saying here. Once I just start this format, I will say it. Multitasking here. Come on, come on. There we go. Trying to unformat. Well, you can't unformat a disk that's, okay, there it is. Oh, it actually was able to save unformat information. Anyways, going pretty quickly there. It's already at 11%. What I was trying to say is, oh yeah, this disk appeared to not be working at all in the original computer with the original controller. Now, that's not to say that I could have just low-leveled it with that original controller, and I actually didn't, I don't even know which controller it was that was paired with this. If it's an XT controller, you gotta like run a little command from the debug to go into the menu that's built into the BIOS on the disk controller to do a low level. Obviously with an XT, with an AT or later, when you have like the 5170 compatible controller, which this gold one is, you can use a program like SpeedStore to do the low level. There's also in this BIOS that's on this machine, you saw it looked a little different than normal. It's a Mr. BIOS. It has a low level format utility as well. I could have used that as well, but anyways, SpeedStore I know how to use, so I used it. Anyhow, this drive may have worked just fine if I had low-leveled it on the XT with the appropriate controller, so there wasn't actually a flaw with this. I've just found I rather use this controller, which I know works, on a machine with other drives that work. It sort of eliminates all the potential problems of, you know, cables being the problem or the controller being bad or who knows what. Because like I showed with that other MFM controller that I was trying to use on this, is yes, controllers do go bad in weird ways and act unpredictably. So anyways, it formatted, it put the system on there. Let's copy some stuff onto here. I'll just copy what's on the A disk drive over to the hard drive. Let's, whatever, we can overwrite command com, that doesn't matter. And wow, this thing's working. Now this is going to be a lot slower than that 43 meg drive that I was using earlier because this has the whole stepper motor, and we'll run, check it, and we'll take a look at that just so you can see that difference. It is copying away. It sounds healthy. Like it's not making any weird noises now that it's running. All sounds good. So let's swap the disk over to check it here. Unfortunately, check it's quite a large program. It doesn't fit on a disk with the other utilities. Alrighty, let's check it out. Hard drive, C, benchmarks. It's gonna be slower. At least the transfer speed should be the same. Oh yeah, 300K per second. Transfer speed's always gonna be basically the same because this drive is running probably at 3600 RPM. So therefore, there's really no reason why it would be any slower or faster than the other drive. It's all about how much data can be transferred over this MFM interface here, which runs at, I think, what was it? I think MFM runs at 6 megabits a second, 6.25 or something, or maybe it's 5 megabits a second. That's how fast the data goes over this. And that pretty much determines the speed the drive can transfer data at. So no matter what kind of drive you have, it's gonna be the same. So yeah, transfer speed is the same, but the seek time is a lot slower. 78 milliseconds maximum, that's edge to edge, and then 17.5 milliseconds track to track seek time. That's a good drive. Let me just park it. Let's see, park. And there it is. Now we turn this off. There we go, pretty quiet. So I'm gonna write my tick mark on here and I will just write type 2 on the top. I know people say, oh, you shouldn't write on the drives, like with a marker, but you know what? It's just easier for me in the future not having to go look up what the details are about a hard drive, and I can just quickly get up and running. Let's get to tick mark and we're gonna write type 2. So that is freaking awesome. At least one drive is actually working. I mean, the first one I was testing obviously worked, but that was one I had determined worked before. This one, yeah, I thought it was dead. I'm glad I didn't just like toss it out before I did proper testing on it. And yeah, there we are. It is good to go. Alrighty, next up is this Miniscribe drive. Now again, I did basically no troubleshooting on this thing other than didn't seem to spin when I powered it up in the machine it was in, which was an XT. So I just took it out and stuck it aside. Let's turn this on. Nothing. Nothing at all. I need to put my ear up to this thing while I power it up, just to see if it makes even the slightest noise, because that can be your indicator if the thing is even trying to spin up versus not. Actually now, you know what, there's like kind of a burning smell coming from it. It's not like it's almost like a hot electronic smell. It's not necessarily burning. All right, well, I think the right thing to do might be to just open this, give it a little push. First, I'm going to try a little bit of percussive maintenance. Oh, look at that. It freaking started spinning. So yeah, that's some stiction right there. That is a pure example of stiction. I didn't even hit it or do any kind of percussive thing to it. And look, blink code. Didn't we see this in my other video? I think we did. Well, let's plug these cables in anyways. Let's see if this thing has any capability of talking to the controller. I have a feeling that is gonna be a big fat no. Now once, of course, it's spun up once, it should spin up easily again. Yep, there it goes. So maybe with the controller hooked up, it'll be more happy and it won't be giving me the blink code. Think what's happening here, besides the stiction, normally on Miniscribe drives, once you power them up, they kind of like do a little initialization with the head. They move it back and forth and stuff like that. And that would be the stepper motor right here. And what can happen, and I made a video about this, which of course I'll link in the description, is it can get gummed up and it will not want to turn. So I'm just going to, this metal structure is kind of in the way. I may need to try to figure out how to take this off. Doesn't look easy to take off, to be honest. Looks like you gotta take the PCB off first, and then it gives you access to take this metal bar off. But I'm just gonna grab a screwdriver. And I am just going to manipulate this thing in here just to see. Okay, it's turning, but it's very, very stiff. Now, the drive is off right now, which means the stepper motor should not be, it's not, well, it shouldn't, it is not energized, which means it should turn a little easier than it is right now. So let's power this up again. When you have stepper motors like this, once you apply power to them, the stepper motor drivers kind of hold the coils energized, and it makes it harder to move once it is energized. So there we go, it's spinning. Let's move this while the drive is spinning. Oh, it's very stiff. Yeah, I can see that it's trying to move there and it's not, and that's why this is giving us the blink code. So what I'm gonna do is I'm gonna drip some bearing oil down into there. We're gonna try to get this working. Now, I have to be totally honest that when you have a drive like this that has a bearing that gets sticky, it's, you know, really needs to be replaced. It's not going to just magically work. Let's see if I can get a couple drops of oil down into the shaft there. Okay, I think I did. Now what you gotta do once you have the oil in there is you gotta kind of keep it where the oil can drip into the bearing. Now these are supposed to be sealed bearings, by the way, so they shouldn't need oil. Like this should be a lifetime bearing. But obviously what's happened is the seal's gone bad. So this oil might free up that stepper and allow this drive to work. Now, like I think I was trying to say, but I cut myself off. This drive has two problems. It has the bad bearing in the stepper motor here, and it's got stiction in the spindle motor, and that just, for whatever reason, maybe the bearings in this are going bad as well. That means that this work might get this drive working, but it's not gonna be reliable. Like it will just fail again at some point in the future. If you use this drive every day, it might work okay for quite a while, but when you store it, it allows everything to kind of seize up again, and then it sort of stops working. So I'm gonna power this up, and while it boots, I'm gonna physically, or sorry, while it starts to spin up, I'm gonna physically move that stepper motor, and we're gonna push it through the motions here. I think it's got like a really sticky spot. Wow. Okay, it's still stuck. So it was trying to do its little initialization, and it kind of has a stiff spot. And what I'm gonna do is just keep powering this thing off and on. And I'm just gonna keep moving that little stepper motor thing here through the stiff spot. All right, here we go. Let's turn this drive off. Hopefully that is in focus. See, that is a stepper motor right there. And it's stuck in that one position right there. So let's just get this going again. So while it's spinning, I'm just gonna try to move it. Let's watch it move on its own. So there it is, it was stuck. It was trying to do a full rotation there and it couldn't. So this again is just like try to move it through the stiff spot in here. Now I don't think you should be moving the heads or the stepper motor that are attached to the heads while the disc is not spinning. Technically, that is where you can damage the disc, and that is the warning that was on the other drive, which is why I'm kind of doing it only while the drive is spinning up or spinning down. So there, I turn it on. There. All right, I think that was good. I think that was good. Still getting a beep code though, or a flash code. Let's just keep doing that though, it's getting better. The more we exercise that motor, the better off this drive may work. No, still getting stuck. So it should be able to continue spinning. Now it's really hard to turn because of course the stepper is energized. It's giving us flash codes. I'm wondering if while it's in this state right now with the flash codes, we can at least send seek commands to it to get it to try to do something. Like if we can exercise the heads, then maybe we can get it past this unhappy spot here where it's obviously where it was parked and where it was sitting for a very long time. It just made the motor get sticky. And this is what we're trying to kind of fight against here. I mean, that sounds normal, but look, still has the beep code. It might just be power cycling like 50 more times. Well, look, the computer says it's waiting for the drive to spin up, so it is not happy. Yep, so the drive is not giving the ready signal back to the machine, which is why on this BIOS, we're getting that thing. Now, some other computers will just sit there and wait, and you won't see any message, but the Mr. BIOS is nice that it tells you what's going on exactly. Nope. I'm just gonna keep power cycling this thing until it maybe comes back to life. I'm just watching the flash code here. So it gives us 2 slow flashes, a quick flashing, and then a 1, and then it's off. All right, well, I found the actual, like, I don't know, the manual, I guess, for this drive. Well, for the ST, well, the MFM version, which is obviously how we're gonna be using this anyways. And it has the error messages on here. Now it does have, by the way, some dip switches. If I scroll back up here, somewhere up here talks about a diagnostic mode, which kind of exercises the heads, which would be nice. Here it is, random seek, crescendo seek. The problem is it says the microprocessor performs a wake-up diagnostic upon application of power. If an error is detected, the processor will flash the warning by blinking the activity LED. Some errors are fatal and do not return to program until power is cycled. Do not return to the program. I guess whatever the main controller is, the program that's on the drive. If no errors are detected, the processor tests the shunt blocks to determine the state of switch 2, 3, and 4, the drive exercise, and then it will run these modes. So it's not going to run these modes because it doesn't get that far. So let's go down and try to decipher the error code. Okay, so error codes are generated in the microprocessor, hardware, or warnings. Error codes are displayed as Morse code. Bits may be interpreted and converted into hex. Zeros are indicated by a short half-second flashing mode. Ones are indicated by a short continuous on. Oh, okay. So 0 is half a second of flashing, which we definitely saw. A 1 is a continuous on. Between bits is half a second, and then between repeat cycles is a full second off. Okay, so let's decipher this. All right, so there's the off, 1, 1, 0, 1, which I'm assuming is 1, 1, 0, 1. I guess like it's the most significant bit is first. So code D, seek error during burn-in or recal. So yeah, seek error kind of is exactly what I thought it is. So I guess even though it seems to be seeking properly because of the oil, it's still not actually working. I guess, I don't know. I think I just need to keep power cycling this thing a whole bunch. Let's flip this upside down like that. See if that makes a difference. Yep, no, this thing is just unhappy. So I've gone ahead and I've spun that stepper motor around several cycles, and it's going through its, so that noise it made there, that implies there's still a problem, like that it made a very high-pitched noise, which I think is it malfunctioning. Well, would you look at that? The drive is actually working now. As you can see, I'm running Speed Store, and it's just doing the random read test, which essentially reads sectors from all over the disk randomly, which is a good way to exercise the head, especially because once the drive works, you can set this to run continually. And it's been reading, well, for quite a while now, 43,000 sectors, or whatever that number is, tracks, I guess, have been read from the disk successfully. Although, as you can see over here, it found 3 bad tracks. I'm going to use a flashlight here to try to shine a little light on the stepper assembly in there so you can see it moving. Hopefully that is actually showing up. Well, take my word for it that it's moving back and forth there pretty quickly. So you might be asking, what was the trick I used to get this drive working? Well, it was nothing more than just powering the drive off and on basically 1,000,000 times, and I kept adding some of this oil there, although it doesn't work super reliably. You hear how it just paused there? That's because occasionally it goes to seek to a specific sector or track, and the stepper does not cooperate, and the drive controller detects that, so it does a recalibration where it kind of resets back to track 0 and then continues on its merry way. When the drive started working, I could tell because, let's stop this actually. Do you want to abort this process? Yes. I'm going to add those defects to the list, and we're going to quit out of here. All right, so let me try to explain what changed and why this drive suddenly started working. Originally, when I was powering on this drive, after lubricating the motor, of course, is the stepper assembly would sort of spin counterclockwise until it hit the bump stop. And then it would sort of move to about over here, and then it would just stop, and then we'd get that flashing error code. Well, I knew that that wasn't right because I've used these drives before, and when they work, what happens is once it hits the bump stop, it then goes several rotations very quickly, I don't know, either to track 0 or maybe to the top track. And that wasn't happening. When it was trying to do that, the motor was just binding up, and that's when the drive controller knows there's a problem, because several rotations should pass that sensor that's in here several times, and that wasn't happening. So when I turn this on now, let's see here, by the way, the stepper motor is quite warm because it's been running for a while. Hopefully you'll see what it does here. Okay, well, that time it didn't even hit the bump stop. Let's power cycle it one more time. Thing is, actually, now that the drive is low leveled, it may not even need to hit the bump stop. Let's see what happens. So it's counterclockwise. Well, then you hear how it has that high-pitched sound? That's the head going several rotations back to a position that the controller expects it to be in. And that's what was not happening. So when I power cycled the drive many, many times and added lubricant and kind of manipulated it and moved it manually back and forth, one of the times I turned it on and then I heard that high-pitched sound, and it spun clockwise a bunch of times, and then I was not getting the flashing light. So I knew that the drive was starting to work. So at that point, with the drive working, and it wasn't working every time, sometimes it would still give the seek error because it wouldn't spin properly, I booted up the system onto Superstore, Speedstore that is, and I started running the diagnostic tests. Now, in order to run that read test that I was doing when I just cut back to the video, the drive needs to be low leveled, and whatever was on here was no longer readable. So I had to low level the drive. There was a problem though. While I tried to low level the drive, it would always sort of get stuck around track 191, and some of the higher tracks would get stuck as well. It had to do with where the motor was in the rotation. Like obviously where it was sitting for however long this thing was sitting, that area became really sticky. And anytime it moved through there quickly or even slowly, it would often bind up. So the tactic was just to continue manipulating it manually, keep trying over and over and over again. And then eventually I was able to get past that part where it couldn't format, and I was able to low level the entire disk. So it is low leveled right now, which means theoretically we could partition the drive right now and then install DOS on here. Now, if we go under diagnostics and we do seek test, this was failing quite a bit because the first thing it does when it does a seek test is it goes to like the extremes of the head back and forth, and that was failing. But this drive has been running for hours and hours, and as I had mentioned, when the drive gets warm, it seems to work better. So here it is doing that extreme seek test. You can kind of hear what it's doing. What was happening originally, it would do it a little bit and then it would make a noise, and it would clunk the heads, and then it would recalibrate, and it would try a few times and then it would fail here. But I think since this thing is nice and warm now, this should probably work plenty reliably. And under diagnostics, it's the read test that I was doing when I cut back to the video, and you just do all this defaults, and now it's going to be doing the random reads. And like I said, originally it would just run this and it would be constantly recalibrating, but the nice thing about this test is it doesn't just abort out as soon as like the drive recalibrates, while on the seek test, it aborts pretty quickly once the drive is recalibrating itself. Alrighty, well, let's try doing partition manager. Let's create a partition. We're gonna make a DOS, largest, it's boot active, so that's good. And I guess we could do format. Nah, let's just exit out of here. I'm gonna do format C/S to install a system on this, so it'll actually boot. And there it goes. It's going pretty quickly too. It's already at 5%. Now I will say that while this drive is working right now, I really don't think it's gonna be particularly reliable in the long run. I mentioned this earlier, when you lubricate the bearings like this, it's really a temporary fix, and ultimately I would only do it and try to get the drive working like I've done here if there were data on here that I could actually read and get off the drive and onto something more reliable. I was actually working on this and kind of got it working last night, and then this morning when I came down to turn on the computer to start exercising the head again, it was recalibrating or retraining the heads quite a lot. It was kind of getting stuck, and you could hear it get stuck. The stepper motor would be moving the head and it would just sort of go, and it would make a weird high-pitched noise, and the drive would recognize there's a problem and it would go to recalibrate the head. So, but as it was just running for a long time and it warmed up, it started working more and more reliably. So I have a feeling if this were, oh, look at this, trying to allocation units, so it's detecting some bad sectors. I think what would happen if you were trying to use this particular drive on a real computer is every time you turned it on, it would be very troublesome and not work very well until the drive kind of warmed up. So it might take 20 minutes of running or 30 minutes of running inside the case before it kind of loosened up those bearings and then worked reliably. All right, just pop the disk out of the drive. Let's reboot this computer. This thing should boot without issue off of this hard drive now. There it goes. Look at that. Pretty quick to boot. There it is. It's all working. All right, let me run check it and we'll see what type of speeds we get out of this drive. Like I had said earlier, I think the speed is gonna be exactly the same as the other drives that have worked so far because of the MFM cables and the interface. It doesn't allow it to go any faster. And there it is, we got 300K per second, which is exactly the same as that other drive. And the seek times, well, they're kind of crappy. The average seek is actually worse than the hard drive that was on the XT, and the track to track is a little bit faster. But it did that seek test without retraining, so that's pretty much a best case scenario for this particular drive. Alrighty, so the Miniscribe drive, it's working, but not very reliably, but it just shows that you can get these working. Next up, let's move to these ST225s and see if I can get this one working that is not responding. First thing I need to do though is plug this into the machine and give it a test. Just make sure that it's behaving exactly the same way as it was when we tested it in the last video. Okay, so the drive is making bad seeky noises, but it is doing something. But the computer, the Mr. BIOS here, is saying it's waiting for the fixed disk to spin up, which we already know means that this drive is not asserting the ready signal here over the controller, which means the computer's just gonna wait indefinitely. And when this does time out, it's just gonna say hard drive error, and this hard drive won't be controllable. And the BIOS says, drive C failure, press any key to continue. What people might be wondering, and let's see if this is the case. Let's boot up into DOS and run SpeedStore. Maybe while the drive is in this weird state where it's giving that error, we can still actually cause it to seek, like running the seek test. Drive is making those clicky noises and the lights on again, because I think what's happening is MS-DOS is querying the disk just to see what's on your partition table wise, which obviously is not going to work. While this thing tries to boot, I'm gonna start removing the screws from the working drive. Oh, it is finally booted into DOS. That took several minutes for it to sit there and kind of try to access the, oh, the disk is corrupted? What happened here? The SpeedStore disk got corrupted. You know what? This is not the first time this happened. I already had to remake this disk once. I really need to make sure this disk is right protected because seemingly SpeedStore, it must be a problem with it on these newer versions of DOS. It seems to kind of corrupt the whole disk. Anyhow, now we have to wait for this whole long boot process again. So what I'm going to do is I'm just going to take off the screws here off this controller to prepare for this swap. I think it is free. I just took out 3 screws. I'm going to be careful about this in case there's like ribbon cables and stuff. I think the right thing to do is to remove the front bezel here as well, because I think there's an LED wire that kind of is short and won't allow us to take the PCB out very easily. Oh, okay, nope. That is not necessary for it to come off. Oh, but the controller's just sort of falling off the drive. Okay, we boot it up into DOS, swap the disk over to the other one. Let's see if this disk is corrupted. It may well be corrupted. Let's see. Let's look in this directory. Oh, it looks okay. Let's run this. And I think what's gonna happen once this starts is gonna try to access this drive and it's gonna make more clicky, terrible noises again. So while it does that, I'm just going to keep looking at this. All right, so the things we have to worry about is there's a thin ribbon cable here. We have to disconnect this. Don't wanna rip that. That is the data cables that goes to the read-write head assembly. So I think what you can do is you can just sort of, so I think you can pry this off using a screwdriver. It's just a pin connector. So just very gently remove it. There it is. So that is free now. And look at that, the controller easily pops up now that we've freed that. So this is the spindle motor cable. So we'll unplug that. And then this is the stepper motor here. There we go. There's a Seagate ST225 controller. When we look at the drive here on the bottom, there's the stepper motor, there's the spindle motor, there's a piece of tape holding that down, and then there is the data cable that goes to the head. So this is the working drive here. So I think a good tactic, once we do a little testing with SpeedStore, is just swap the 2 controllers around. I'll put this controller on that drive, and we'll see if the badness follows the controller, or if it stays with the drive. Alrighty, so let's do some diagnostics on here. So controller test passes. Let's see if it does seeking. Nah, so it's not even seeking properly. It is trying to control the drive though. So even though the drive's not ready, it's still at least attempting to do something. Okay, well, I'm gonna board out of this because I don't think we're gonna get anywhere. This drive, it is just refusing to do any operation at all. So let's swap this over. So just like on the other one, we remove these 3 screws, remove the front panel because you do have to do that to disconnect that head data cable. It goes to the read-write heads. And before I actually power this up, everyone should put in the comment section below what you think is gonna happen. Is this drive gonna work with the other controller, or is it gonna not work because there's actually a mechanical problem inside the drive itself? Alrighty, there is the head disconnected, and the cable, it's in good shape. I don't see any problems with it. Okay, let's flip this up. Take a look inside. It all looks very similar, if not identical. Unplug these 2 controller cables. So I talked about this in the last video. I thought there might be a problem with the head amplifier, and I think it's this IC right here. It's an ST11642-001, so it's some kind of a custom jobby. There's also a Motorola chip here labeled 11665-001. You know what? Those might be standard chips, and that those are just custom part numbers that Seagate has. But the connector here, I can see the traces. It runs mainly over to this IC right here. So this IC could well be the problem. Part of the issue, of course, is it's not really possible to run this in a way that you can like poke the top side of the board, because with everything connected, there's just not enough length. It has to run this way. At least you can probe the backside, but yeah, that's not ideal. I need to mark these. I'm gonna put a W on this one because we know this is working. So this is the one I just took off the working drive. Actually, no, that is the one that's off the bad drive. So I'm gonna make it look like a sideways B. Okay, so this is the bad controller. I'm gonna put this on the working drive, and I'm gonna take this and we'll stick this onto this drive. Now it's definitely my hope that this bad drive doesn't cause any kind of damage to this good controller here. It's totally possible. There could be some kind of a short circuit or something inside the head assembly or whatever that's causing this to go wrong. Make sure that's on correctly. It is. I'm gonna put these screws back on just in case they're used for some grounding, because the solder mask is removed on those spots, so those definitely have some function, it looks like, for grounding of some kind. Okay, so that one is done, and I'm just gonna do the same thing on this drive because we're gonna test both of them. All right, so there we have it. So this is the controller that was from the bad drive, but this is in the drive that was working. Doesn't say bad or anything on it, it just says type 2. And this drive is the one that was spinning but not working, and it's got the controller that was good. So now's your last chance to put your guess down in the comment section on which of these 2 drives you think is gonna work. Why don't we just go for it and let's test the one that was not working with the new controller, see how it goes. Okay, moment of truth, here we go. Drive is spinning up, good sign, of course. The green light is on the front. Okay, this sounds the same. Ah, okay. Same exact problem, exactly the same problem. So let's turn this off and swap to the other drive. I have a feeling we are gonna find that the other one works and that the problem exists entirely inside the mechanical part of the drive. Now, what could be wrong? I don't know. I guess we'll have to open it up and see if we can see a problem inside. All right, here we go with the working drive with the controller from the other one. Huh. Oh, it worked. It's booting. That's it. It's actually booting off the hard drive right now. So yeah, okay. As I was saying, unlike newer controllers, these are dumb controllers, meaning like what's on the drive doesn't contain like bad sectors or any other special information. As long as you're swapping the controller from 2 same drives, like ST225s, then you should be good. As you can see right here, it's booting up perfectly off the working drive with the bad controller. So let me park the heads and turn this one off. And you do have to park the heads on the ST225. On the ST251, you do not. It auto parks. This one you do. Because what I wanted to do is take a look at the stepper motor while it's operating. And maybe it is just a binding problem and I need to put some oil in there, just like I did on the other drive, and that'll make this thing work. Let's turn this on and we should hopefully see this moving. Let's see, let's just point the screwdriver at it. Nope, there it moved normally. It sounds like right now it's actually hitting the bump stop because it's not turning at all. And then I can see it goes counterclockwise, clockwise. There it is, counterclockwise, then clockwise, and then it's just hitting the bump stop. So let's open it up. Let's take a look inside. All right, here we go. Let's see, what do we got? Alrighty, so there is the drive, very simplistic. Let's turn this on. Let's see what the heads do. So it's hitting the bump stop. This is the bump stop. See what's up against it. I guess there is no track 0 sensor on this drive, actually. It's very simplistic. What I can see a lot of, and I don't know if this is going to be visible, but there's like a lot of like fluff or something, a lot of like what looks like corrosion right there, and it's flaked off quite a bit. So if I turn off the power to this, I can move this all the way there, and if we turn it on, you'll see what it will do is it will slowly move the head back to the bump stop. So there it goes, moving it towards the bump stop. And there, I hit the bump stop. So everything seems to be moving very freely, but it is just not working. So my assumption is it's not a problem with the stepper motor at all. These stepper motors are pretty reliable. It is something with the read-write head assembly, and there's this crust here, which I think might be related to what's going on. Maybe these read-write heads are no longer connected to this ribbon cable, and that has caused it to be unable to read the disc, which makes it very unhappy and very unable to locate itself on the platters. I wanted to try to get a close-up view there of that corrosion on there that I was talking about. So this brown crustiness here, don't know what that is, but look at this. See, it's all crusty right there along the wires that run on the heads there. So I'm thinking that these wires are broken or something. They don't seem to be broken, but it's very hard to tell what's going on. All this crustiness shouldn't be there. You don't think you should have a bunch of dirty crustiness inside your hard drive, which is going to cause it to not work properly. Right there. I don't even know if this is in focus, and I apologize if it's not. This camera, unfortunately, does not have the best macro focus capabilities. Oh, and I just, when I was able to peel off this glue, it sort of fell off pretty easily, and it definitely, well, I kind of made it worse, but it looks like some of the, well, the middle read-write heads were no longer connected anymore. One of them was, the other one looks like it wasn't. So that head is not working anymore at all. And the bottom one, let's see. Looks like the bottom one is also not connected any longer. The top one is, though. That's the only one that looks like it is connected. Let's just spin it up. I'm just curious what it does right now. It's probably going to do exactly the same thing. And of course, it's doing the exact same thing. And of course it would, because I'm pretty sure whatever's wrong with this drive definitely happened in that area right there. So let's just power this off. At least you got to see inside a Seagate ST225. It is a pretty simple design, but it's pretty elegant. And, you know, obviously when stuff like that doesn't happen, it's pretty reliable as well. These drives just work quite well because look, there's just not a lot going on. We have a single pivot there. We have a stepper motor that has a metal drive belt that just moves the actuator here. There's a bump stop. There's a ribbon cable that goes to the main controller. The spindle motor with the discs. It's all just pretty simple stuff. It's too bad that whatever glue they used, well, turned corrosive. And I think that was the demise of this drive. As far as this controller goes, we know that both controllers work just fine. So what I'm probably gonna do is I'll just take this off and I'll save this controller in case I ever have another 225 in the future that has a bad controller on it, then I can just swap that over. But the rest of this thing is gonna go bye-bye. Alrighty, that's gonna be it for this video. We had 3 bad drives and we came out of it with one that fully works perfectly. This NEC drive just works. The Miniscribe drive mostly works. I'm not gonna say it's reliable, but I could at least use it in a pinch. 20 megabytes, and while it didn't spin before because I had some stiction, that seems to be solved. Just pull that off. But of course the problem is the stepper motor, which is working, but not trustworthy. But hopefully I showed a few techniques for getting these working just in case you need to try to revive them to get you some data off of them. And then we have the Seagate ST225. The one that was not working was this one. controller swap resulted in a still non-working drive, and then after opening up inside, we found that it seemed like the head assembly had some corrosion on it, which almost certainly ate through those very delicate wires, which caused this to not work. I did come out of it with an extra ST225 drive controller, which can go with the drive that does work here. And I think I might have a couple more of these drives that actually work as well. So this is probably a good spare part board to keep, but the rest of this thing, it's gonna go to e-waste. So hopefully you enjoyed this video, me fiddling around with these old MFM or ST506 type drives, and maybe you picked up a thing or two from the techniques I use to try to get these working. They are a bit of a pain, but as I mentioned in my last videos, there are the occasional time when you do have to use these because you're using it with a computer that has no capability of accepting an XT IDE card like this or some other kind of modern drive replacement. There is actually an ST506 emulator, and I've talked about it in previous videos, and it has the same type of connector here. So if you're using a computer that only takes this type of drive, you can use that particular emulator if it's an MFM interface. The emulator is somewhat costly. I think there are some others on the market too, and they are pretty expensive compared to something like an XT IDE where you drop this into a PC and it just works. Or of course, if it's a regular IDE drive, you can just use these compact flash to IDE adapters because a compact flash card is an IDE device. As I was saying, I got one working drive, one kind of working drive out of this, and that's better than what I expected because generally these drives are so unbelievably unreliable. So thumbs up if you liked this video, thumbs down if you didn't. Hit that subscribe button if you haven't already. Patrons are scrolling up the side of the screen here. They get early access to videos, other cool behind the scenes stuff. And yeah, I think that's gonna be it, the usual YouTube stuff. So stay healthy, stay safe. I will see you next time. Bye.